Hello everyone and welcome to course number 1, Review and Preparation. This is the Flight Controls and Control Surfaces course 280-5A5. Context of this course in the program. This is at your 5th semester of the program. The Maintenance and Aircraft Flight Controls and Control Surfaces course prepares the students for general maintenance techniques of aircraft flight controls and control surfaces. Now, if we look at the course outline, which I've just finished preparing but not approved yet, so there might be some slight changes in the semester. The general context of the course in the program, if we look at the important stuff here, upon completion of this course, students will develop the ability to gather the necessary information to perform a task, plan the work, apply procedures and standards, perform maintenance activities related to flight controls, and store and clean the workplace after you're done your work. Competence of the graduate: perform maintenance on aircraft systems. Department objective: perform maintenance of flight controls and control surfaces. Now, if you look at the theory part, this semester is a bit special. We have 14 weeks instead of 15. We'll have a first part of the course, which will be week 1, 2, 3, 4, and 5 theory, distance. We'll put some videos like this one on YouTube with a study document like you're used to with me. At week 6, we'll have a exam 1, which will be in presence. So because the group is quite small, so we can actually handle that. For the rest of the semester, there might be some changes. I know I have 2, 7 and 8, which I have material. Then we do research on technical manuals and a semester assignment, which was a presentation from you guys in front of the class. I'll see if we can do that. Otherwise, we'll try to figure out another system. At the end of the semester, week 14, we're going to have a second exam. So, again, this is the, in theory, system evaluation method. Exam 1, exam 2, as you can see, that was at the one of the week 6 or so, and week 14, and session work or assignment, and that was worth 10%. We'll see how we go about that one. For the lab portion, as you know, we have divided the groups in two, group alpha and group Bravo, and you alternate from one to the other one. But you still have a little homework to do in between those attendances, because we need to give some hours for Transport Canada. Otherwise, your time for your license will be compromised. This is the laboratory summative evaluation method. You have a mechanical drawing to do. This is worth 5%, and it's due around week. It says week 4, but I believe it's week 6. But we'll verify. Exam 1, week 7. Semester work or an assignment, which will be on layout. That would be to be ended in at the end of the semester, week 14. As always, exam number 2, which is in presence, and that's worth 30% for a total of 60. Mandatory required material, study documents, and also laboratory documents that will be available on layout. You have to print those, you need those in class. You're going to need a drawing sheet 11 by 17. That's available at the co-op, and I believe it's like 10 or 15 or 25 cents or something like that. Also, safety glasses, safety shoes, approved clothing for the laboratory, and I guess also a face mask. Passing mark, as you know, is 60. Blah blah blah. Any questions on the course outline? If so, just let me know and send me a mail or something if you think it's an A. That's my bad. So if you have questions on the outline, you can always bring that up next time we see us in lab, or you can send me a mail and we'll discuss about it. If you think it's a question that regards everybody, just make sure you copy everyone.
All right, so let's go. Let's see into the now. Early efforts at fixed-wing aircraft design succeeded in generating sufficient lift for the aircraft to get off the ground. But once airborne, it was a little bit difficult to control and often ended in disaster, as you can see from this little video. So you can, yeah, they were pretty good at lifting off, but then controlling was another story. The Blériot 11 is now in a museum in Paris. You notice anything strange on those wings? Yeah, ailerons. So early airplanes did not have any ailerons. Instead, they relied on wing warping for lateral control of the airplane. Now they were actually warping the wing in order to control the aircraft. The Wright brothers are credited for developing the first practical control surface. It is the main part of their patent on. By 1915, ailerons have become more popular than the wing warping. So ailerons were actually invented and described in a British scientist by a British scientist and metaphysicist Matthew Pierce Watts Bolton in 1864 on a paper that he wrote about aerial locomotion. He was the first to patent aileron control systems in 1868, so 35 years before the Wright brothers actually took flight. Hinge component surfaces they have the advantage of not causing any stresses on the structure that are a problem with wing warping, because wing warping actually have to create a structure that was rigid enough to support flight, but flexible enough to be able to warp. So that was pretty complicated. But again, in those days, they were made out of wood, so not as stiff as today's structures. Although, if you look at the wings on modern aircrafts, they are pretty flexible. Actually, sometimes it can be scary to see how flexible those wings are. Today, effective and reliable flight controls play a key role in flight safety. Vast majority of aircraft currently in service follow the basic principle demonstrated in this course. This course will prepare you guys for general maintenance techniques on aircraft flight controls and control surface. Little review. Flight controls and control surfaces. What's the difference? What are they and what's the difference? Well, flight controls is any device, lever, pedal, steering wheel, etc. that the pilot uses to steer the aircraft in the desired direction. Now, this is what we call the flight controls, because that allows you for controlling the aircraft. Then you have the control surfaces. That's any movable part of the aircraft that are used to control the direction of the airplane by modifying. If you look at a modern cockpit, well, you have the yoke, You have the elevator trim, usually on the thumb rest of the steering wheel. This will allow for trimming. We'll see what that is um, in a few more slides. Rudder pedals, you have flaps control, you have flight spoilers. So all these are flight controls. Of course, throttle is also considered as a flight control because it allows for acceleration, deceleration, which will increase lift or decrease lift. And of course, the autopilot, which interacts with the control surfaces. On another example here, smaller aircraft, yoke control, elevator trim. On smaller aircrafts, usually it's manual. It's not electric. Well, in some cases can be, but most of the small aircrafts, they have manual. On helicopters, although we're not going to see those too much, we're going to leave that for the guys from the helicopter courses. But you have the anti-torque pedals. You have the collective pitch control with the throttle at the end, cyclic control pitch, which allows for the movement of the aircraft. Throttle, I just mentioned. So control surfaces may be derived from divided in three categories: primary, secondary, and tertiary flight control. So essentially, primary flight control surfaces are aileron, rudder, and elevator. So this is the primary flight controls, meaning they're always present on an aircraft. And these are used to control the three flight axes: pitch, roll, and yaw. I like that one. Yaw. Secondary flight control surfaces, not always used on aircraft, but on most, yes, meaning these are used to increase or decrease lift during specific portions of the flight, essentially takeoff and landing, really. So you can see in this case here, a Challenger, you can see the flaps. Spoilers and air brakes are used to decrease lift and reduce the speed of the aircraft. There's ground spoilers and flight spoilers. We'll see those in the coming weeks. Tertiary flight control surfaces are essentially trim controls that allow the pilot to balance the lift and drag being produced by the wings and the control surfaces. They are used to reduce the effort required to maintain a desired flight attitude. So, as the aircraft flies, usually fuel is consumed, so the CG of the aircraft or center of gravity of the aircraft will change during flight, meaning that you have to put a little bit more effort in, for example, keeping the nose up of the aircraft. So in order to reduce that effort, we can actually trim the elevator so that the aircraft is balanced again. So that means that essentially, as you fly, you will always have to correct a little bit the pitch trim in order for the aircraft to fly level as the fuel decreases. All control surfaces have the same purpose. What's that purpose? Actually, to modify aerodynamics. What we want to do is either or reduce or increase the drag, sort of. So FZ, you've probably seen this already, this formula in your aerodynamics class. Fz being the lift and Fx being the drag. Now, dynamic pressure, have rho V2. You have the surface or area of the control surface. Coefficient of lift, Cz. Coefficient of drag, Cx. So, in this case here, you can see that the first formula will increase lift, meaning the top one. You can actually increase lift by lowering the aileron. And if you raise the aileron, you will actually decrease the lift. So lift goes down. Newton's law. First law or principle of inertia, every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. Stability is the key of first Newton. Then we have the second law. Force acting on a body is equal to the acceleration of that body times its mass. For every action, there's an equal and opposite reaction. If you're flying forward, there's also drag involved. So if we, in other words, I mean, the size of the forces on the first object equals the size of the force. So there's flight controls and there's control surfaces. Flight controls inside the cockpit, control surfaces outside the aircraft. So what's between the two? It's got to be something that connects them. Linkage. We'll see there's different types of linkages, and some are mechanical, some are electrical. We're going to see that a little bit more in. Some aircraft use cables and pulleys to transmit pilot's command to the control surfaces. I would say most aircraft use cables and pulleys because even today, Boeing, for example, the 737, the infamous 737 Max, still uses cables. Okay, it's not a fly-by-wire aircraft. So most use cables. This is referred as soft linkage. Other ones, they use tubes and bell cranks. Now this, again, most aircraft today, and sometimes it's a combination of both. In this case here, as you can see in the drawing, this is a Dornier. You have those tubes. They're called torque tubes. And you have the cables. So cable, pulleys, and tubes. This is the portion that is with tubes is referred as rigid linkage. Here's an example of a schematic of a rudder. So rudder pedals are here. Everything is linked through tubes. In this case, you have a servo hydraulic actuator, and we'll see that a little bit more in details. You're going to see that also. I think you have already done the hydraulics course. If not, servo actuators will be discussed in that course. You have the control surface in the back here, and there's something called artificial feel that is to allow pilots to feel the aerodynamic forces that is acting on, in this case, the rudder. Here you can see the Challenger 604. So not going into too many details in this, but there's a power drive unit. This is for the flaps here. So we'll see that in lab a little bit more in detail. Flying basics. Force exerted on the aircraft, on a flying aircraft, you have dream to fly, you have the reality or gravity that pulls you down, you have the money who makes you go faster, and you have, of course, FAA and Transport Canada that is dragging you or trying to slow you down. Actually, these are not the exerted forces, these are the forces. So lift, weight or gravity, again, the lift is fighting against the weight of the aircraft, the thrust is fighting against the drag of the aircraft. So you got more thrust and drag, you're flying. If it's the opposite, you're not going anywhere. So to make a roll to the left, pilot must do something in the cockpit. So what is he going to do? He's going to push the yoke or turn the steering wheel to the left. So if you have a steering wheel, you're going to turn it to the left. If you have a yoke, you're going to push it to the left. This will move the control surfaces. In this case here, as you can see, the left aileron is raised and the right aileron is lowered. This will this will lower the wing on this side because it decreases the lift. This will actually raise the wing because you're increasing the lift. The pilot wants to move the aircraft around the vertical axis. What is he going to do? What is the name of that movement? We saw that earlier. It's yaw. What is he? He's going to step on the right rudder pedal. Stepping on the right rudder pedal, sorry. What happens to the control surface? The rudder is going to turn to the right. This is going to push the not the rudder, but the vertical stabilizer into that direction, because you're increasing the lift on this side, decreasing the lift on the other side. Pilot engages in the landing approach to move the aircraft nose down. What is he going to do? He's going to push forward on the yoke. Now, pushing forward on the yoke is known as pitch down, of course. And what happens to the control surface in this case here? It's the elevator. The elevator goes down. Elevator down means you increase the lift on the upper side of the wing or the elevator. And by doing this, it's going to raise the tail of the aircraft and pitching the nose down. But flying is not that simple. You're not only moving one control at the time. Flight is a result of coordinated movement of the control. For example, if the pilot wants to turn left and keep climbing, he's going to have to use two control surfaces. So he's going to use all three axes, pitch, yaw, and roll, in order to coordinate the maneuver. Well, if you want to turn and keep climbing, it's the three, because if you don't want the aircraft to slip or slide, then you're gonna have to use the yaw axis or the rudder at the same time. So the three axes are used in order to maintain a good coordinated turn. Example 2. The external elements also have an influence on the flight. Of course, if you have a crosswind, like this here, your trajectory, you're going forward. This little red line indicates it's a little yaw we put on the windshield, and that gives you a information or indication of the wind. So crosswind goes like this. If you're going forward, that means you are actually slipping. So you're slipping to the right. That's why the little yarn is tilted to the, it's attached here, let's say. So this is free to move, and it moves to the right. So the aircraft is slipping to the left in this case, as shown by the red yarn in the windshield. To do what in order to stabilize the aircraft? Well, you're going to have to do a little movement. You're going to have to turn the nose of the aircraft into the wind, meaning a little bit more into this direction in order to keep going forward. And this will be achieved by stepping on the right rudder pedal what we say, what pilots say, it's step on the ball. So TBI is the turn and bank indicator. This you've probably seen in the instrument class already, so I won't get too much into details. So in this case here, if you turn the aircraft to the right, you're going into the wind. So once the nose of the aircraft is into the wind, can the pilot return to the rudder in the center? Well, yes, actually, if you're flying directly in the wind, you don't have to compensate for the crosswind anymore. Difference between skid and slip in a turn. So during a skid, the aircraft is driven by centrifugal force, meaning you're turning, but you're actually slipping out of the turn. During a slide, the aircraft is actually driven by gravity, meaning the centrifugal force is not as strong, so the aircraft is actually losing altitude. So driven by gravity means you're actually losing altitude. So in order to avoid that, you have to compensate with rudder. So a coordinated turn, you have to compensate with rudder and a little bit more elevator in order to maintain altitude you're turning. Example 3. Upon returning to the base, the pilot complains that the airplane is left wing heavy, meaning it has a tendency, the left wing has a tendency to go lower by itself. So how do we correct this situation? Well, actually, ailerons are often equipped with little trim tabs. You may have seen this already on aircrafts and don't know what it is. It's like a little piece of metal that is sticking out at the trailing edge. This is what we call a trim tab. This is not a movable trim tab, or it's adjustable on the ground. Movable meaning you cannot control it from the cockpit, but it's a little piece of aluminum that you can to correct the situation. So if you bend up that little trim tab, the change of curvature in its section will increase the lift, because if you're moving this up, that little tab, well, it will push on the control surface. It will push down on the control surface. In this case here, this will cause more lift to be produced by that elevator, and this will actually correct the situation of the heavy left wing. Now, this is done on the ground by technicians. You're going to move that little tab up a little bit, and of course you have to go for a test flight and see if it's enough or not enough or too much bend, and readjust. So it's a trial and error thing. It's not something that you can actually do in flight. All right, so basically this puts the grounds for the first course, for the flight controls and control surfaces course. If you have any questions, like I said earlier, you can send me a mail if you think it's a question that may help your fellow classmates. Just copy everybody on the question. Otherwise, just send me a little question. If you have something particular, you can refer to the slide number. That would help me find the information for you. All right, so till the next course, take care, stay safe, and can't wait to hear from you guys. Bye bye.